what are we going to talk about today? Factorials, permutations, and combinations. And what the heck is all this? Well, what we're going to do is we have to consider three different situations. One, you have 3 books. How many ways can you arrange them on a shelf? The second thing is, if you had 10 books, how many ways can you grab 3 and arrange them on a shelf? And the third is, you have 10 books. How many ways can you just choose 3 to take with you on a trip? Meaning not arrange them. We're going to consider those 3 different situations. So on the top of your notebook paper, this is just a regular thing of notebook, separate into 3 columns. We're going to compare arrange, to pick and arrange, and then to just choosing. And we're going to just do a bunch of stuff below arrange, and we're going to see how that pick and arrange compares to that and how just choosing compares to that. So there's a lot of notes to take, but you can do it. So let's just start by talking about arranging, okay? I'm going to consider 3 books, and how many ways could I arrange 3 books? Let's see. Well, if the books are called A, B, and C, I could have put them in like this, A, B, C, or A, C, B, or B first, and then A, C, B, C, A, or C first, A, B, C, B, A. So it looks like there's one. I can't think of any other ways to do it besides those. And how did I come up with those? I just kind of shuffled them around in my head. But if I had to do it for 13 books or 27 books, it would be really hard to write them all out. So I need to think of a logical way to approach this. So what I do is I think of positions on the shelf, and I say, well, let's think about maybe the first position, the second position, and the third position on this shelf. In the first position, I could have put A there, B there, or C there. So I started at a point. I could either have had A, B, C. So there's basically 3 options at first. Okay. But after I put A in the first position, the only thing that was left for the second position was B and C. And if I chose B first, I only have A and C left. And if I put C in the first position, it would just give me A or B left. Now, assuming I put A first and then B, what's left for me? Only C's left in the third position. Likewise, if I did AC, only B would be left, BA only C, BC only A, CA only B, and CB only A left. So if you think about this in terms of positions on the shelf, what do we actually have? We actually had 3 options in the first position, leaving 2 options left for the second position and 1 at the end. And if you notice, 3 times 2 times 1 gives me those 6 arrangements overall. So, and they were the upper road ABC, and then ACB, AB, and then BAC, then BCA, and then CAB and CBA. This 3 times 2 times 1 actually has a special name. It's called factorial. And it's an exclamation point. 3 factorial equals 3 times 2 times 1, which equals 6, right? So it basically tells us how many ways you can arrange 3 objects. Cool. Well, what if I want to know how many ways I could arrange 5 objects? So how many ways for 5? Well, it would be 5 factorial. There's 5 positions. Well, you could put all 5 books in the first position, then there's only 4 left for the next, and then 3, and then 2, and then 1. And 5 times 4 is 20. 3 times 2 is 6. 6 times 20 is 120 ways. There's 120 ways to arrange 5 books. Okay. Now, we call n factorial is often written like this, n factorial, and it's written n times n minus 1 times n minus 2 ... to 2 times 1 all the way down. There's actually a place on your calculator that will do it. Okay. Your calculator, if you go from math over to probability, and then you go over to the exclamation point, that's where it is on your calculator. It's under the probability under TI. So you can do 10 factorial without doing 10 times 9 times 8 times 7. Do that all out, and you end up getting 3628800, I hope. So if you have 10 books and you're like, oh, I'm going to mess around and see how long it takes me to arrange them in all the ways, don't do it! Because there's 3.5 million ways you can arrange 10 books. It goes up really quickly. So if I was going to ask you how many ways to arrange 6 books, I'm hoping now, 6 books? You can say, oh, that's easy. 6 times 5 times 4 times 3 times 2 times 1. And in that case, you can do that 6 times, oh, look at this. I get 30, 12 times 2, 3 times 12, 3, 6, 720 ways. All right, cool. And you can do that on your calculator also. So that's factorial. All right. Now I'm bringing you over to pick and arrange. Whoa, let me readjust this. I'm going to pause this just for 1 second. All right, now I have 10 books on the shelf, A, B, C, D, E, F, G, H, I, all on the shelf, and I have to arrange just 3 of them. So let's just go back to the considering 3 positions. I have 3 positions again, 1, 2, 3, but now I have 10 books. So I can put 10 here, but once I use up one of the books, guess what? There's only 9 left for the second position and 8. So I end up having 10 times 9 times 8, which is 720 ways I can arrange 3 books out of 10. Now we want to create a formula out of that. Now notice this thing looks a lot like 10 factorial. Interesting. And let's think. 10 factorial, in fact, would be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. I only want 10 times 9 times 8. I want to get rid of the 7, 6, 5, 4, 3, 2, 1. What is 7, 6, 5, 4, 3, 2, 1? I'm hoping you're looking at that right now saying, that's 7 factorial. And if that's what you're thinking, you're darn right. So how do I get rid of 7 factorial? I know you're thinking, subtract 7 factorial. And you're wrong. I can't subtract 7 factorial from here. This is a product. Because here I'm multiplying by 7, 6, 5. How do I undo multiplication? The way you undo multiplication is by division. So if I divide by 7 factorial, now I'm dividing by 7 times 6 times 5 times 4 times 3 times 2 times 1. And guess what? Hallelujah, hallelujah, hallelujah. Yes, you get it. 10 factorial over 7 factorial is 10 times 9 times 8. And that gives you what you wanted, which is 720. Which are the ways you can arrange 3 books on a shelf if you choose them from 10. Now, notice 7 factorial is the same thing as 10 minus the number you are choosing factorial. So I could rewrite this thing as 10 factorial over 10 minus 3 factorial. And in fact, that is a special thing in math that we do called permutations, which is 10 pick and arrange 3. 10 pick and arrange 3 is called a permutation, which is arrange 3 out of 10. So you're picking and arranging. Now the nerdy way you're going to see this is generally like this: out of n, pick and arrange k things. And then it's written like this: n factorial over n minus k factorial. And it seems like wow, you're like, how am I going to remember all that? That's crazy. I can't do that. Well, it's the same thing as here. It was 10 factorial over 10 minus 3. That 10 minus 3 gave you the 7 because you just want to have k left over. So when you do n subtract k, you get left with just k stuff, and you'll see it. And I can give you an example right now. Like, suppose I wanted to see arrange 4 out of 9. Well, here I'm going to do is 9 pick and arrange 4. I'll put my 9 factorial up top, and on the bottom will be n minus k, 9 minus 4 factorial, which give me 5 factorial. And it makes sense because think about this. I have 4 spots, right? There's 9 for there, then there's 8 left, 7, 6. So I want to end with 9, 8, 7, 6. Let's see if this works out. What is 9 factorial over 9 minus 4 factorial? It's 9 factorial over 5 factorial, which is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 5 times 4 times 3 times 2 times 1. What happens with my 5, 4, 3, 2, 1? Hiya! And what's left? 9 times 8 times 7 times 6, which is exactly what I wanted in the first place. 3024, which is 3024 ways. Okay. Well, you can get this on your calculator also. You go math over to probability. Then you go to something called NPR. And you type it in like this. 9 NPR 4 will give you 3024. Okay. So these problems often come out like they're like, how many ways out of 9 people, how many ways can I choose a president, a vice president, a secretary, and a treasurer? Well, 1, 2, you're arranging them, so it's going to be 3024. That would be the answer to that. Now, I got to pause for a second and go to class, but I'm going to do the last column in a minute. Oh, wait a minute. My camera's off. All righty. And then we're just going to do the last one is just choosing 10 books from 3. So now we're just going to choose books and take them along with us. So if we consider the calculation we just did, when we took 10, pick and arrange 3, there was an overcount, certainly for choosing. If we're considering just grabbing, and what do I mean? I mean, because suppose I did all the ways that I could grab like the first 3 books. 10p permutation will count taking A, B, C, or A, C, B, or B, A, C, or B, C, A, or C, A, B, or C, B, A. It will count these as 6 different groups. But these are all the same. These are all the same. And all the arrangements of these 3 books are counted. So since these 6 arrangements are counted 6 times over here, so we basically have an overcount, permutations, overcount by a factor of 3 factorial, which is the 6 ways that I could arrange those 3 books. So I need to basically divide to undo that. I need to divide by 3 factorial. So what I need to actually do is I need to do 10 factorial over 7 factorial, but also divided by 3 factorial to make up for it. All right, which is kind of crazy. And when I do that, notice I end up with something called 10 choose 3, which is a combination. Okay, which is just choosing 3 out of 10. Now, we see this written kind of fancily. The fancy way to write it is n choose k. You have your n factorial up top, k factorial, and then n minus k factorial, which will be the exact same thing as this. My 10 up top. Then how many am I choosing? 3. And then 10 minus 3 gives me that 7. N minus k gives me that n minus k. One observation, these 2 bottom numbers always add up to the top. 3 and 7 will equal 10. And it makes sense because k plus n minus k, the k's cancel out and you end up with n, right? So these 2 numbers will always add up to n. Something to notice. But if I was going to show you the actual the other way, there's another way you'll see this. It's often written like this, 10 choose 3, and they write it like that. It's not 10 over 3, it's just 10 with a 3 below it. That's the same thing as 10 choose 3, n choose k, so this would be n over k. So the other way you could see that as 10 choose 3, I'll write it here, 10 choose 3. Now if I want to do this thing out, what will it look like? Oh, let's see. Well, I've got 10 factorial over 3 factorial times 7 factorial. It looks like this. 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And look what happens. Here we go. See ya, see ya, see ya. Wouldn't want to be ya. And then I have my 3 times 2 times 1. Let's reduce these guys. That becomes 3. That becomes 4. 10 times 3 times 4 is 120. So there's 120 ways that I could choose that. 120 ways. Kind of cool. And if you put it in your calculator, don't forget there's a nice shortcut. You go to Stat, over to Probability, over to NCR, and you're going to type in 10 NCR, choosing 3, and what do you end up getting? Let's see. You get your 120 again. All right, so that can do that. Also, it's kind of cool. Hopefully that makes sense. One little tidbit you may think is interesting. The Pascal's triangle, which is made like this. You add these two numbers, and it's got a bunch of ones. If I wanted to do something like choose 2 out of 2, out of 5, choose 2, I could go down to row 5, 0, 1, 2, and that would give me 10 options. But also notice that 5, choose 3 is also 10. So meaning if I want to do these, if I went down to the 10th row and over 3, I'd get 120 if this thing kept going. But the question is, why is out of 5 choosing 2 the same thing as out of 5 choosing 3? Well, if I'm choosing 2 books to take with me, it's the same thing as choosing 3 books to not take with me. When I go back to this thing, NCR3, guess what? If I do 10 NCR7, guess what it's going to give me? 720, because if you stop and think about it, it's not just the symmetry you see right here. There's symmetry in Pascal's triangle, but think about it. If I'm choosing 3 books to take with me on a trip, it's the same thing as choosing 7 books to not take with me. So those are combinations. So the big 3 that we're talking about here, easy to mix up, but they're 3 very separate things. I'm going to zoom this out old-fashioned way. Arranging 3 books is just n factorial, okay? The arrangements, you just go through n factorial. If I'm going to pick and arrange, if I'm going to choose, I'm going to pick and arrange. Picking and arranging is permutation, right? But if I'm just going to choose 3 to take with me on a trip and not arrange them at all, guess what? That's called a combination, all right? The cool thing about doing these combinations is the canceling out. I think it's wonderful. I think it's a lot of fun. I like to do it. Sometimes I do it on my free time. So hopefully that made sense to you. Have a great day.